Hello, girls. How have you been? This is Madam Dimna. It has been a long holiday. I had planned to have a lesson with you, but I've been a bit held up. So today, I organized to have a lesson with you, and one of the topics that I felt I should go through is on the service area of solids. Hope you are doing well. Welcome to the lesson. So in the introduction part of it, what I can say on this topic is a good one. It is a topic related to the two other topics, one in Form 1, another one in Form 4. Still, we have another topic in Form 2, that is which comes after this one, volume of solids. So it is connected to those three topics. So if you need to get good marks, then master the three topics, the four topics actually. That is, we have a topic in Form 1, area of solids, another topic in Form 2, volume of solids. Then in Form 4, we have three-dimension geometry, of which you may find questions set from the three or the four topics, and they are joined together to give you 10 marks. So you need to go through the four topics if you need to get good marks. That is, for now, we have done the area of solids. You did it with me. I covered surface area of solids, and we did volume of solids, but I realized that some of you are not getting some of the concepts in the surface area of solids, so let us revise it together, and then by the end of the lesson, I think you will be comfortable to handle it. So in the introduction part of it, I can say that a solid is an object with a definite shape. It has a definite shape and size. Some of the solids that we are going to look at, they are prisms, pyramids, frustrums of these pyramids. We have frustrum of a cone, frustrum of the right pyramids, and then we have spheres. And the application part of it, you may find these solids joined together. A cone joined to a sphere, pyramids, frustrums of pyramids joined together with another shape to form a solid. So when we find the surface area of a solid, we sum the areas of all the faces that are given in that solid. So whenever you come across such a question, first try to identify how many faces are there in that solid. Is it closed? Is it open? Before you handle that question. So the first part of that topic is the surface area of a prism, and you need to understand what is a prism. A prism is a solid with a uniform cross-section. Examples of those prisms, we have a cylinder having a circular cross-section. This circular here, circular end, it is uniform to this end here. Then we have another example, is this hexagonal prism. Hexagonal prism has a polygonal end with an hexagon. So this part is the same as the one that is on the other end. It is a uniform cross-section. We usually have, if I can consider the top part of this solid here, we usually have triangular prisms. So if I take the upper part from here upwards, this is a triangular prism. It is joined to a cuboid. So we have a rectangular part and a triangular part. So you can have them in a separate form or you can have them joined together. So we have many other prisms that you can come across. If you use revision books and other materials, you may find many other examples that you can list. So as you find the area of these prisms, you said you identify how many faces are there. Like for this cylinder, it has two circular ends if it is closed, and then we have this curved part here. of which we learned that if you cut it at a given point and try to open that curved part, it will form a rectangle. Then this one has this face and the other end, that is a hexagonal part, and then we have the rectangular faces, of which there are 6. This one you can also count how many faces it has. It has this face joined to the rectangular, to the rectangle and the triangle. We have this one times 2, this one times 2, and then we have the bottom. So to the calculations, how will you do, or how will you handle the calculations on those prisms? Let us go through those examples. Like, how can we find the area, the surface area of that cylinder with a radius of 2.8 centimeters and the length of 13? That length is like the height of the cylinder. So we said it's finding the area of the circular ends plus the area of the curved part. Sorry for that. So the cylinder, the circular end, the radius is 2.8 and the length is 13. So finding the area, the surface area of that cylinder is the area of the 2 circular ends and the area of the curved part, because it is a closed one. So it will be twice, that is 2 pi r squared plus 2 pi r l. You substitute in that formula using the figures given there. We have 2 times 22 over 7 times 2.8 times 2.8 plus 2 times 22 over 7 times 2.8 times 13. That is the L, which is the same as the height. Then you can press your calculators, get the values as 49.28 plus 228.8, which gives you 278.08 square centimeters. That is the total area, surface area for that cylinder. If it is an open cylinder, then it means you will only include the bottom, that is pi r squared. So it will not be twice pi r squared, it will be just pi r squared plus 2 pi r l. And some can use pi d l, because twice the radius makes the diameter. So it is still okay. The second example, which involves that hexagonal prism, we start with that uniform cross section. It is of a hexagon, and finding the area of the hexagon, we did this under the area of quadrilaterals, whereby we realized that you subdivide that hexagon into triangular faces. If you subdivide it, like if it is 6-sided, it will form 6 triangles. If it is 8-sided, it will form 8 triangles. So we'll have a different number of triangles depending on the polygon. So for this one, the information given here is the one that will guide you on how you will calculate for the area of those triangles. So like in this case, we have the angle given here, the center is 60 degrees. Theta is 60 degrees. But at the same time, we know that angles at a point add up to 360 degrees. So if you take 360 degrees, divide by 6, it will give you that one angle here is measuring 60 degrees. Then the side given, this length here, it is the one that is given as 6 centimeters. So how can you calculate the area of this? Given this one is 60, a triangle adds up to 180. So 180 minus 60, it will be 120. So hapa ni 120, the two angles, the base angles are 120. This side inatoshana na hii. Hizi side zinatoshana hizi hapa katikati. So kama zinatoshana, it means the base angles are equal. So 120 divided by 2, the two base angles, 120 divided by 2, you realize that it will give you 60 degrees, 60 degrees. So that makes you to realize this triangle is an equilateral triangle. So how can we find that area? We can use the sine formula. We did 3 formulas of finding the area of a triangle. You remember them? The common one, which you did even from primary, a half base times height. Sine formula, I have AB sine theta. Hero's formula, which you use S, you remember it very well. For this case, now that we have the two, like we can use the two sides, this and that, 6 centimeters, 6 centimeters. The base tumepata hapa pia ni 60 degrees. Or you can use this 60, 6, 6. The angle must be an included angle between two given sides. So you will use a half AB sine theta, which is for one triangle, times how many triangles? 1, 2, 3, 4, 5, 6. To give you one hexagonal end. And remember there are two, this and the other one. So it means after finding the area of this one, you'll multiply by 2. Then for the triangular, not triangular, sorry, but the rectangular faces, hizi ziko hapa. There are 6 of them. If you can count with the number of sides, there are 6. So these ones, there are also 6. So this side is measuring 6. The other one is measuring, we were given that it is measuring 15. So it will be 6 by 15. So if you can go to the working, how do we find that surface area? Area of the hexagonal ends plus area of the 6 rectangular faces. Hello, are we there? Hope you're paying attention. Area of the hexagonal ends plus the area of the 6 rectangular faces. Area of the hexagon ndio hiyo tumesema a half times 6 times 6 sine 60. And there are 6 of them, you multiply by 6. And there are 2 sides, uniform cross section, 2 times that. So tukisubstitute ndio hiyo maana tumeandika 2 into 6 into a half times 6 times 6 sine 6. This one is for one triangle times 6 of them. Then times 2 for the 2 hexagonal ends. Then we come to the area of the rectangular faces. 6 times 15. And there are 6 of them. You multiply by 6. So you press your calculators, do it very well. You will end up with 727.06 square centimeters. And it is well done. So what I want to be clear about here, nimesema this side, these triangular faces can be done in different ways depending on the information given. Here, tuliangukia a case whereby the sides are rectangular. Sorry for that. Sorry for that. Come later, I'm in class. Sorry for that. Remember, I'm doing this lesson from the house, so those disturbances, they are allowed. So I was saying that in this case, when we have, if we have different lengths or different information whereby it is not an equilateral triangle, remember you can apply other formulas like a half base times height. You can subdivide this triangle to form a half base times height, whereby, like I said, it depends with the information given. So you can use even Hero's formula to calculate the area of a triangle. So don't be fixed to one formula. I know you are clever girls, you can apply that. Then the third example, for the third example here, where we have this figure with different faces. It is a prism with, because of this cross section here, it is uniform. It inafanana the other end, so it forms a uniform cross section. So finding the area of this one, there are some of the faces, they are rectangular, like the top here, E face times 2 inatoshana na yenye iko the other end, that is D times C. We also have, it will be C times E. Then we have this one, C times A. There are two of them. Then we have A times B plus a half A, a half times E times D. This, there is a right angle shown here. So it forms a right angle triangle here. So the cross section, this cross section here, itakuwa ni A times B plus a half times E times D. Then there are two of them, we multiply by 2. Then come to the bottom, B times C. So you have to identify how many faces are there in that solid. So tuko na bottom, tuko na hii face hapa, this one C times the height is A. Tuko na hii uniform cross section na tuko na this one yenye inafanana what is here. So the values are given. A is 4 centimeters, B 5 centimeters, C 8 centimeters, D 4 centimeters. So you can substitute accordingly, like we have A times B, that is the cross section, A times B plus a half times E times D. Then we multiply by 2. That is what I said. Alafu tukiendelea, so this is twice. The cross section, A times B plus a half times E times D. So this 2 is multiplied because it is, the faces are 2. Then you come to the other end, C times A times 2. C times A, C times A. The height, this height here is A times C. So this face and the other face which is on the other side. So it is C times A times 2. But when it comes to this one, it is D times C. Kutoka hapa mpaka hapa ni C. Then we have D. So this is a rectangular face pia. Ukikuja hapa, we cannot multiply this one by 2. Remember that we cannot multiply by 2 because E is not equal to D. They are different lengths. So it will be E times D. So after doing that, you sum all those faces, all those areas. So C times B, C times D, C times E, including the base. And if you work out all that, you will end up getting 212 square centimeters. Good. Then that is how we deal with prisms. Identify how many faces are there. Is it an open prism? Is it opening at one end like that and then do the working? Then if I can move to surface area of a pyramid, that is where I'll stop. Let us go through the pyramid and then we'll stop there. At least you digest that first. A pyramid is a solid with a polygonal base and slanting sides that meet at a common apex. Is a solid with a polygonal base and slanting sides that meet at a common apex. So in this case, we can get a base, a pyramid with a square base. We can get a pyramid with a rectangular base. At the same time, we can get a pyramid with a triangular base or any other shape. You should be ready for that. I know we have got used to a case whereby we have a rectangular base, a square base. We forget about that triangular. It is also there. That is why we have said that it has a polygonal base. We have not specified that it's a square or a rectangular only. You go through revision books, you can get those other pyramids being drawn there. So how do we find the surface area of those pyramids? We find the sum of the area of the slanting faces and the area of the base. I have a figure here of a right pyramid with a square base of side x centimeters and a slanting height of t centimeters. And the perpendicular height is h centimeters. The perpendicular height is usually referred as the height. And the slanting height is the height for those triangular faces. Kuna hiyo height ya triangle, which is down there. So for the perpendicular height, it's from the apex to the bottom of that pyramid. I can illustrate here. So this one here, VO is the perpendicular height. But if I draw from V to this point here, it will give us the slant height for that triangle. So one thing you need to remember, this height, the perpendicular height meets the base at a right angle. So if you join this V to C or V to D, V to A, not V, sorry, O to A, O to D, O to C, and O to B, you will form a right angled triangle. That is like triangle VOC is right angled at O. VOD, VOD is right angled at O. That information will assist you when you're doing your calculation. At the same time, if I can draw a line from O to this point here, to the midpoint of the side CD, it will also form a right angle triangle. So depending on the information given in a question, you may use that concept to calculate some of the lengths that will assist you to get the surface area. Hope we are there. Hope you're not dosing, you're following what we are doing. Higher. So there's an example here, a worked example on how to get a surface area of a right pyramid with a square base of 4 centimeters. The slanting edge is measuring 8. Slanting edge, if I can refer to this example, is like V, A, C, D, and B. This one, A, B, C, and D. So those are the slanting edges. Umepewa 8 centimeters. It is drawn down here. Like Vx here is 8. So inamaanisha Vx is equal to Vw, Vu, and is equal to Vy. The base is indicated is measuring 4 by 4. So the base is direct. Finding the area of a square, 4 by 4, you get 16. Finding the area of the triangular faces. When it is square-based, it is easier. When you see it, you should start smiling because it requires less effort. Like you find the area of one triangular face, you multiply by 4 of them. So for this one, the area of one face, like this one, it is measuring 8, hapa ni 8, the base is 4. It is an isosceles triangle. So you drop a line here to form the height, the slant height for that triangle. Getting that height, if you divide Wx, it will be 2, 2, 2. So ukichora hiyo line hapo, getting the area of the triangle itakuwa ni 8, not the area of the triangle, but the height, sorry. It will be 8 squared minus 2 squared, you find the square root. 8 acts as the hypotenuse of that triangle. So 8 squared minus 2 squared, you find the square root. It will give you the height of this face. Then now finding the area of the triangular faces, it will be a half times 4, which is the base, times the height, which you will have calculated, times the 4 triangular faces. 1, 2, 3, 4. That is what is done here. Surface area, base area, plus the area of the 4 triangular faces. 4 by 4, the area of the base, plus 4 into a half times 4 times the height, which is 8 squared minus 2 squared. If you do that working, these 2 cancels with 4 here to make it 2, then times the 4 times the height. You sum them, you'll end up with 77.97 square centimeters. Good. What about a right pyramid with a rectangular base? It has a rectangular base of 6 by 4 and a height of 9 centimeters. 6 by 4, that is the base. So inamaanisha in this case, we have the triangular faces, it is opposite triangular faces that are equal. The ones that are opposite to each other, the ones that are equal. The ones with 6, a base of 6, and there are 2 with a base of 4. So how will we do it? The height is 9 centimeters. That is the perpendicular height. For this case, you need to move step by step for you to get the measurements that you'll use in calculating the area of the triangular faces. It needs some steps. 1, you need to get the slant height for this triangular base. And in order for you to get the slant height for this triangular face and for this other face with a base of 6, you will have to calculate the slant edges. Slanting edges. The slanting edges are TQ, TR, TS, and TP. How will you do that? Remember we said the height meets the base at a right angle. And we have the rectangular base measuring 6 by 4. Remember, the sides of a rectangle, they meet at a right angle. That is, they meet at 90 degrees. The sides of a rectangle, they meet at 90 degrees. Like at P, we SPQ. SPQ is 90 degrees. So you can calculate SQ, which acts as the hypotenuse of that triangle. So that will be PS is 4, PQ is 6. 4 squared plus 6 squared, you find the square root, it will give you SQ. So that is what is done here. 6 squared plus 4 squared, find the square root, will give you 7.211. Always give your answer to 4 figures. A reason why you are using calculators and a reason why you are using 4 figures, the 4-figure table. You should not truncate or round off unnecessarily. Try to give all the calculations in 4 figures unless advised to give it in different decimal places. So getting OQ, we're interested with getting the slant height first. The slant edge, is slant edge, like TQ. So tukipata SQ, we divide by 2, we'll get OQ. This will assist us. We'll have a right angle, which is a right triangle, which is TOQ. TOQ. So that if we have TO and OQ, we can get TQ. So OQ is a half of SQ. A half of 7.211 will be 3.606. So neglect this word slanting edge. It's not the slanting edge. It's just SQ. It's OQ, sorry. So it's not the slanting edge. So now you will take, to get TQ, it will be 9 squared plus 3.606 squared. You find the square root, it will give you TQ. So inamaanisha hiyo TQ is equal to TR, it's equal to TS and TP. The 4 edges are equal. On getting TQ, which is this one, TQ, umepata ni 9.695. Now you will have to move to another step of finding the height of those triangular faces. We don't have it will be, sometimes the learners, you can use Hero's formula, yes? But I know most of the learners don't like Euros formula. They get confused on the way because we have the measurements here. A learner can decide to use Euros formula. Umepata the slant edges. You have the base. Now you want the area of this triangle. You can go for Euros formula. You can get S, substitute in Euros formula, and you get the area of one face, then times 2. And for the other face, you use the same process. The slant edges, they are equal. So you can as well get the sum, the perimeter, get S, substitute in Euros formula, you get the area of one face, then you multiply by 2. The two opposite faces are the ones that are equal. TQR is equal to TPS. TPQ is equal to TRS. Just like that. But if you want to use the height, I have base times height, then it means again, after getting the slant edges, you'll go ahead and calculate the slant heights. Whereby, this is TQ acts as the hypotenuse. The base, it will be a half of 4, which is 2. So it will be 9.695 squared minus 2 squared. It will give you that height on finding the square root. That will be for one triangle with a base of 4. That is what is indicated here. The height of the triangular faces with a base of 4, it will be 9.695 squared minus 2 squared. Find the square root. It will give you 9.487. You move ahead to get the height of the triangular faces with a base of 6. Use the same steps, Pythagoras theorem. Remember, slanting edges zinatoshana. So 9.695 squared minus 3 squared. Find the square root. It will give you 9.220. So that is the height for that triangular face with a base of 6. Good. So we have obtained the heights. Sarong, ukimaster haikuwa refu sana. And remember, in this case, you have calculators. Pressing a calculator 1, 2, 3 like that, you are done. So you should not be worried. Understanding the steps is good. And then now you do practice and then you apply it. And remember, we are reviewing this topic. And I've done it several times even in school. So you should not be worried. I want you, the moment you get it, you go for all the marks. We want good marks. Haya, back to this. Surface area of that pyramid now. A pyramid with a rectangular base of height 9 centimeters. The base is 6 by 4. So, to starting with the base, itakuwa 6 by 4, which is 24. The slanting faces, this triangle times 2. This other triangle here, triangle TPQ times 2. So itakuwa ni a half times, for this triangle, itakuwa a half times 4 times the height that you will have obtained there, which is this one. Tulikuwa tumepata 9.487. And the other one itakuwa a half times 6 times 9.220. And there are two faces times 2. So this is what is done here. 6 times 4 for the base. 2 into a half times 4 times 9.487 plus 2 into a half times 6 times that for the triangular face with a base of 6, with a base of 4. There are two of them times 2. Na hii times 2. Uziongeze 117.3. And you're done. You're good to go. You smile. Hesabu sio ngumu msichana. So, that is all about today's lesson. Hope you have enjoyed the lesson and it has assisted you to review this area. I would like to get your feedback. You can chat through our Google Classroom. You should be conversant with that and give a way forward. So we'll have our next lesson we go through other solids, especially the frustrants, and then we'll be through. So I need like another session to go through that. So my assignments from KLB, exercise 13.1, please attempt question 7. If you can go to that exercise, it is there. The reason why I requested that you request your parents, they buy you KLB textbooks. Those textbooks will assist you at home, even in school. Instead of sharing few textbooks in a class, will move faster when you have your own textbook. While at home, when you're given assignment like now, you can easily refer to your own textbook. It's not that you are benefiting the school. Please request the parents. I know they are pressed. They may not have money. I requested for book 2 and book 3 because once we finish book 2, we'll move to form 3 work. But if a parent cannot manage to buy book 3 and book 2 and 3 right now, he can buy book 2, and then as you come back, he'll be struggling to get book 3 for you. But for MedFarm as well, it is a good revision book. It will make the questions be familiar with you. You check on how questions are set in various years, and then you will be good to go. So just talk to the parents politely and request them for the same. My assignment, I said, is from exercise 13.1, question 7. Then you can go ahead and find another one, which has, especially now here, you can do part A for what I've gone through. But remember, we have done everything on this. You can as well attempt part B. Then you consult when necessary. So, good day. All the best. Bye. Bye-bye. Take care.